It's all about trigonometry and the wave equation and how we measure rotations in circles. So I've started off with some definitions of radians and degrees, because we measure angles in two ways. We either measure angles arbitrarily in terms of degrees, 360 degrees in a circle, or we measure it in terms of radians, which is the one that you may not be quite so familiar with. So let's have a look at this here. Here is a circle that you have in front of you. We consider this circle with radius r, so we use little r to represent the radius. So if you think about this circle, if I were to measure out a distance around the circle which is equal to the radius, then I would get the same angle regardless of the size of the circle. If the circle was this size, for example, then the radius would be here, and that would be the arc length, as we call it. So you can see that as the radius increases, the arc length increases. And if I make the ratio of the arc length to the radius equal to 1, then I've got 1 radian. So if we think about that in terms of the circle, well then if I were to think of the circumference of the circle as 2 pi r, which we know, then if I were to think of the radian as 1, because I've gone around 1, the ratio is 1, then 1 complete turn is 2 pi radians, 2 pi lots of the radius. So if I let that radius equal 1, then 2 pi radians in 1 circle. So that's where the idea of 2 pi radians being in 1 complete circle comes from. And so that's summarized here. If I want to find the arc length, the distance, in other words, I've travelled around a circle, and often in mechanics we're considering rotating objects. So an object starts here and then rotates round. And I'm often interested in how far around this circle have I actually gone. What is this arc length, in other words? Well, the arc length is just given by the length of the radius times the angle, but measured in radians. So if I measure my angle in radians rather than degrees, all I need to do is multiply this angle by the radius, and I've got the arc length. So a useful formula to measure how far around the circle I've gone if I use radians rather than degrees. Often I need to convert from degrees to radians or radians to degrees, and so it's useful to be able to do that. First off, all I remember about this is, well, I know what a complete turn is, it's 360 degrees. And I know what a complete turn is in radians, it's 2 pi. So that's the only fact I have in my head. After that, I can work it out. So if 2 pi radians is 360 degrees, what's pi? 180. Must be 180 degrees, mustn't it? So in other words, pi radians is halfway around a circle. 1/2 a revolution. I can use a similar idea for half pi. What's pi over 2 in terms of degrees? 90. So these are key ones to remember in a way, but they come from this. That's all you have to remember. But people often remember these. 90 degrees is the same as pi over 2, or 180 degrees is the same as pi radians. And I could follow the same argument for 1/3 of pi. What would I do? What must that be? Right, 60 degrees, because pi is 180, 1/3 of that is 60 degrees. But of course, I also want to be able to work out, well, what's 360 degrees? Sorry, 36 degrees. That's 1/10 of 2 pi, isn't it? 0.2 pi. But it would be worth thinking about, well, what's 1 degree? So if 360 degrees is 2 pi radians, what do I do to get 1 degree? If 360 degrees is 2 pi radians, what's 1 degree? What do I do? Divide 2 pi by 360. Yeah. If 360 degrees is 2 pi radians, think about this for a minute, because this is what goes on in your head. Remember I said at the beginning, all I have to do is remember this So if I know that, if 360 degrees is 2 pi radians, then 1 degree must be 2 pi divided by 360, mustn't it? So 2 pi divided by 360, well, that's the same as pi divided by 180. So you can either remember it as 2 pi divided by 360 or pi divided by 180. Now if I know that, and I want to work out what, say, 5 degrees is, I've done it, haven't I? If I know that 1 degree is pi over 180, then 5 degrees must be that times 5, and so on. So I can find out, do any conversion going from degrees to radians. I might also want to go the other way. So if 2 pi radians is 360 degrees, what's 1 radian? If 2 pi radians is 360 degrees, what's 1 radian? Same argument. (360 degrees divided by 2 pi, I heard someone say. Or 180 divided by pi. So you can either try and remember those two little things, or you can just work it out if you remember 2 pi is 360. Now if I know what 1 radian is, I can work out what 2 radians is, or 3 radians is, or half a radian is. I just times by that. So if I want to know what 2 radians is, I times that by 2, and so on. So that's how you convert from one to the other. So what is, by the way, there's chapter 19, exercises 75 and 76 is all about this sort of degrees to radians and circles and things. Can do. So yeah, so if I want to convert, say, 3 pi radians to degrees, I'll put 3 pi in my calculator and then times it by 180 over pi. But what can I do without, rather than use a calculator, what can I do with that to simplify things? Well, I can cancel out the pi's, can't I, if you look at that? So it's just 180 times 3. Which is why we often leave radians in terms of pi, because they then cancel out when you're trying to convert back to degrees again. So that's what's 3, that's 188, that's 54, isn't it? 540 degrees. And so on. I can convert any. So what is 0.5 for radians in degrees? What is 19 degrees in radians? Just have a go at those two and I'll pause. So if we look at these answers, I think 97.2 degrees and 0.33 radians, or that's what the group thinks. Well, what do? Look at this information underneath. 2 pi radians is 360. So I want to know what 0.54 radians is. So I need to know what 1 radian is. So 2 pi radians is 360. So 1 radian must be 360 over 2 pi. So then I times that by 0.54. For the other one, I could do with what 1 degree is. So 1 degree must be 2 pi over 360. And then I times that by 19. So that's the sort of idea. In fact, slight correction, 31 degrees for the first one. But that's what you do. And this is hopefully what you got in mind. This is the idea. Okay, I'll stop that there.